Hey, geometry students, we are to 6.4, which is the converse of the Pythagorean theorem, and this is actually the last skill for this unit, so very short unit. Before we get started with talking about what the converse of the Pythagorean theorem is, I thought it would be useful to know what the converse of something is in math. And basically all it is it reverses a statement. So basically if you say something in one order, a converse reverses the order of that statement. So the Pythagorean theorem, I just abbreviated it as PT here. So the Pythagorean theorem says that if it's a right triangle, if you're dealing with a right triangle, then c squared is equal to a squared plus b squared. Okay, and that's what we've been talking about, the Pythagorean theorem. The converse of the Pythagorean theorem reverses the order. It says that if c squared is equal to a squared plus b squared, then you're dealing with a right triangle. Okay, the difference here, or what we kind of need to add to this, is that we can't call c the hypotenuse necessarily, because we don't know for sure when we're starting a problem like this if it is a right triangle or not. So instead, we're just going to say it's the longest side. So if the longest side squared is equal to the sum of the shorter two sides, squared, then it is a right triangle. So that's the converse of the Pythagorean. So with the Pythagorean, or the converse of the Pythagorean theorem, there's two other things that are really pretty cool and go with it. So what they say is that if c squared is larger than a squared plus b squared, then you're dealing with an obtuse triangle. Okay, so I think I'll maybe even draw a picture of this too. So say we have like a and a b and a c. If you have a situation like that, where c squared is larger than a squared plus b squared, then it's an obtuse triangle. And if c squared is less than a squared plus b squared, then it's going to be an acute triangle. So maybe it's like something like this, where here's c and here's a and here's b. Okay, so those are the three things that we're going to work on today. If c squared equals a squared plus b squared, it's right. If c squared is greater than a squared plus b squared, it's obtuse. And if c squared is less than a squared plus b squared, it's acute. Okay, one more thing that's going to come up in this lesson, and this is kind of a long one, so I apologize in advance. We need to check to make sure that the three numbers we're given are actually capable of forming a triangle. So we did this at the beginning of the year, where we talked about the short plus the middle has to be bigger than the long. So in this case, if you tried it, if you did 2 plus 5 and asked yourself, is that bigger than 10? You're going to have 7 bigger than 10? And no, that doesn't work. Okay, so that wouldn't create a triangle. So we need to make sure that we're checking each of these before we go ahead with the converse of the Pythagorean theorem. Okay, this one over here, it does work. If you had 2, 5, and 6, so once again, small, medium, and large, you would end up with 2 plus 5 bigger than 6, 7 bigger than 6, and the answer there would be yes, that would work. So just a reminder, we're going to have to do that for each of these examples. All right, so we're going to go ahead and do 3 examples. One, or in all of our examples. First, what we're going to do is decide that whether the 3 sides form a right triangle, and then if they do, is it right, acute, or obtuse? So first example, we have sides of 2, 12, and 9. So step 1, check and see if it's actually a triangle. So 2 is small, 9 is medium, 12 is large. Let's double check. Let's do 2 plus 9 and see, is that bigger than 12? Well, 2 plus 9 is only 11, and 11 is not bigger than 12. So this one does not make a triangle. So that's kind of good news. It's less work for us. We don't have to do any more than that because those 3 sides don't even form a triangle. All right, example 2. 5, 7, and 9. So this one, it's in order, which is nice. We have small, medium, and large. So we can go ahead and check it. 5 plus 7 bigger than 9. 5 plus 7 is, would that be 12? And 12 is definitely bigger than 9. So yes, it does make a triangle, so we can continue with the converse of the Pythagorean theorem. Okay, now with the converse of the Pythagorean theorem, I'm going to show you how I always do these problems, and then if that makes sense to you, you can certainly do them the same way. So I do this. I do c squared box a squared plus b squared. Okay, in that box is either going to be an equal sign, a less than sign, or a greater than sign, depending on what happens with our problem here. So what we need to do is take the biggest number, take your large, and that goes in for C. And then your other two numbers, your small and your medium, they go in for A and B. And the order doesn't matter. You could do small plus medium, medium plus small, doesn't matter. Just make sure that your largest one is your C. Okay, so then we're going to do 9 squared, because that's our largest number, box, 5 squared plus 7 squared. And then we're actually going to evaluate. So 9 squared is 81. And then what I usually do is I just grab a calculator and type in the rest of it. So 5 squared plus 7 squared, just type that in together. So 5 squared plus 7 squared, and you get 74. Okay, so now you decide which inequality sign goes in there, or is it an equal sign? Remember all the way back from like elementary school? Alligator eats the bigger number. So alligator is going to eat the 81. And then if we look back really quick to this one right here, we just did this symbol. Therefore, it is an obtuse triangle. C squared was greater than a squared plus b squared. So this would create an obtuse triangle. All right. And let's look at another example. This one is going to take a little bit of effort, but that's okay. Effort is good. Because looking at those numbers, I'm not really even convinced which one is smallest and medium and large. And if I don't know, then I'm guessing a lot of you don't know either. So what we're going to do is we're just going to find decimal approximations for each of these just so that we can determine which is the largest side. That's really all we need to know, is which one's biggest. So I'm going to grab a calculator and I'm going to do 2 square root of 3, square root of 3, and square root of 15. So those into Desmos, and it looks like the biggest one is the square root of 15, which is about 3.87, which doesn't really matter. We don't need those decimal approximations at all. Like I said, we just needed to know which side was the biggest. So square root of 15 is the biggest side. So when we go back here, we're just going to label these as what they were. So this was our largest, and this must have been our middle, and this was our smallest side. Okay, so first thing is to check and make sure that it is in fact a triangle. So we need to do, is the square root of 3 plus 2 square roots of 3 bigger than the square root of 15? That is our question. Okay, so I'm just going to go back to the calculator once again, and we just need to add up the square root of 3 plus 2 square roots of 3. So basically, I'll just type them in. So 2 square roots of 3 plus the square root of 3. And we get like 5.20, which is definitely bigger than the square root of 15, which is 3.87. So it is a triangle. So I'm just going to answer that question right away. Yes, it is a triangle. Okay, then we're going to do this thing where we ask ourselves, what is c squared compared to a squared plus b squared? Okay, so remember that biggest one, that is the biggest thing we need to remember in here. That goes first. So we need to do the square root of 15 squared box a squared, and the order of those doesn't matter, so I'll just do square root of 3 squared plus, and then I'm going to take this one and I'm going to make sure that it goes in parentheses. So 2 square roots of 3 squared, because we need to make sure that whole entire thing gets squared. Okay, now the math here is actually really simple. It looks complicated, but it's really not bad at all. Okay, square root of 15 squared is just 15. It's that easy. Square root of 15 squared is 15. Square root of 3 squared, it's just 3. It's really easy. Okay? This next part, a little bit more work. We need to do 2 squared. 2 squared is 4. It needs to get multiplied by the square root of 3 squared, which is just 3. Okay? So now what we're doing is we are asking ourselves, what this is. 4 times 3 is 12. So we have 3 plus 12. So we end up with 15 bucks. 3 plus 12 is 15, and they're equal. The left side equals the right side. So therefore, we are dealing with a right triangle. All right, so I think this lesson's pretty cool. Kind of nifty that you can decide what a triangle looks like without even having a picture of the triangle, just based on the numbers that represent the sides. So that's it for this lesson, and that's it for this unit, notes-wise at least. So this unit, what we're going to do is you're going to take the test when you're ready, as long as it is before Friday. So you need to complete the 6.4 practice and mastery check. You need to complete the Unit 6 review and then show that to me. Once I have seen all of your notes, practice, mastery checks, and then that review for the unit, I will open up that Schoology test for you, and then you can go ahead and take that. So as always, let me know if you have any questions on any of this as you work through it. Good luck.